12A, voting. Does the majority always rule? When we only have two candidates or two choices, and if everyone votes, then someone will have more than half of the vote. This is called majority rule. Majority rule is important in that it has three interesting things. Each vote counts the same. There's symmetry between the candidate. So if we swap the candidate, if we swap the votes, the outcome, okay, the winner becomes a loser, the loser becomes the winner. And the third thing is if someone changes their mind and instead of voting for the loser, they decide to vote for the winner, the outcome will not be changed. What happens when we have three or more choices? In this case, none of them have a majority. So what should we do? There are many different ways that we can approach this problem. There's not one method that's better than the other. They all have some sort of unfairness to it. We're going to go through the 5 different methods. The first method is called plurality. The person with the most votes wins, even if they don't have majority. In this case, Garcia is the plurality winner. In many elections around the world, most countries will have a race where they will have a runoff between the top 2 vote getters. So what will happen is this. After the first vote, the 2 candidates with the most votes will have something called a runoff, which is another round of the election. So it's the 2-round election. And in this case, the winner of the second round is the winner of the election. So in this particular example, Garcia has the most votes, and Kim comes in at number 2. So what we'll do is we'll vote again in the second election with only Garcia and Kim. And we'll see if one of them gets more votes and ends up with a majority. Now, in this case, because the people who voted for Smith, the 320 people who voted for Smith, have to vote for someone else, we need to know who they would prefer if they cannot vote for Smith. In order to do that, we need something called a preference schedule. A preference schedule is something like this. We look at it column by column. And in the first column, the 320 people will vote for Smith if they can. If Smith is not one of the choice, they will vote for Kim instead. And if Kim is not around, sure, they will vote for Garcia. This is called a preference schedule. And so we read them column by column. So the 330 people on the second column, they will vote for Kim first, and then Smith, and then Garcia. Now, because Smith is not an option, so Smith is practically not there, right? We cannot choose Smith. So in this case, these 320 people, they will vote for Kim. The 330 people over here, they will still vote for Kim, right? Because Kim is still around. They will still vote for Kim. The 175 here, they will vote for Garcia. And the 175 in the fourth column will vote for Garcia. So in this case, Kim will get 320 votes plus 330 votes, 650, whereas Garcia only gets 350 votes. Now, this is the result if we have this preference schedule. And we'll tell you what the preference schedule is. In real life, you have to, of course, go ask everyone and ask them, oh, who's your first choice? Who's your second choice? Who's your third choice? For the questions that you'll get, you'll be provided you'll be given a preference schedule and use that to determine who wins the election. In this case, Kim is the winner for the single runoff. Something similar to the single runoff is called the sequential runoff. A sequential runoff will vote many, many times, and each time in each round, the candidate or the choice with the lowest vote gets eliminated. And this is used often in elections where everyone, all the voters sit around, and we can go through all the options really fast. We can vote really fast. This even occurs sometimes when you go out with your friends and you're deciding what to eat or which movie to see. You ask everyone, oh, what's their first choice? And the choice that the least number of people chooses, perhaps only one person wants to watch a documentary. And what you'll do is you'll talk to that person and you'll say, no one wants to watch documentary. That's the least number of votes. Choose something else. Choose something else that everyone, that's one of the choice that other people are voting for. This is a little bit like, say, a singing contest, where each round, the candidate with the lowest number of votes get eliminated one by one, week by week, until there's a final winner. Since we only have 3 candidates, we can only do runoff one time. So in this particular case, sequential runoff is the same. But if we have 4 candidates, we'll have to eliminate the lowest vote getter, and we'll have 3 choices. We'll vote again, and then we'll have 2 choices, and then before we determine the winner. Whereas the top 2 runoff, there's only always 2 rounds. The fourth method that we'll talk about is the point system. We give points to coming in first, coming in second, or coming in third in the ballot. The way we vote for, say, MVPs or the most valuable pitcher or the best goalie in sports, in North American sports, we usually do something similar to the point system, except we don't always assign points to, say, the 4th place, 5th place, 6th place. In the point system that we are talking about here, we are assigning points to all positions. So what we're going to do is we're going to look at the points. We're going to look at the preference schedule, and we're going to tally up Smith's point total. So what you'll have to do is you'll have to go back to the previous page, and we are looking at Smith. And you'll notice the 320 people voted for Smith first. In this case, because we have 3 different choices, the points are 1 point for the third choice, 2 points for the second choice, 3 points for the first choice. So in this case, we have 3 points for Smith coming in first. We have 320 who wanted Smith first. So 3 points times 320. On the second column, we find Smith in the second spot. Second choice is worth 2 points each. 330 people voted for Smith in that spot. Oops, 330. And in the fourth column, you can do them separately. In the example that we show you, we do them together. We add up all the second place number of votes for the second place finishes. But you can do them separately, column by column. I find that more systematic. So in the third column, Smith also gets 2 points for being the second choice. And there are 175 people who chooses Smith second. And finally, in the last column, we're still looking at Smith. Remember, we're counting all the points that Smith gets. Smith, in this case, is the third choice, so they only get 1 point, and we have 175 people who voted for Smith in that spot. So let's go back. So you'll see how I have 3 times 320, 2 times 330, and 2 times 175. You'll notice over here, we add up the votes before we multiply the points. It's the same. We will do the same thing for the 3 candidates. So it's a little bit of work. The candidate with the most points wins. In this case, Kim has the most points. Kim will win. Finally, the last method is called pairwise comparison. We have to compare each candidate one-on-one. It's a little bit like determining which team in the league is the best team. What you will do most of the time is you have each team play each other at one time. And you'll find out who wins the most, who has the most number of wins, which team has the most number of wins. The team with the most number of wins wins the competition. So we'll have to go back and look at the preference schedule. And you'll notice if I compare Smith and Kim together, Kim has more votes. So Kim wins this comparison. Kim wins this game. When Smith compares with Garcia, Smith has more votes. When Kim compares with Garcia, Kim has more votes. And you notice in this case, Kim has 2 wins. Smith only have 1 win, and Garcia went winless. Because Kim has 2 wins, Kim is the winner by pairwise comparison. Let's look at an example. Here we have a bigger preference schedule, a more complicated one. Who is the plurality winner? Now, A in this case has 18 votes. A has 18. B has 12. C has 10. D has 9. But now notice E, there are 2 different columns who picks E first. So E actually has 6 votes in total. The candidate with the most number of wins is A. A has 18 votes, so A is the plurality winner. Now, what if we need to do a runoff between the top 2 candidates? When we vote after the first round, you'll notice that A has 18 votes, B has 12 votes, so A and B are the 2 candidates with the most number of votes. What we'll then do is we'll then do a runoff between them. We'll compare A and B, and we'll see who has the most votes if I vote again in the second round. In the second round, 18 people will vote for A still. 12 people will vote for B. The 10 people who originally voted for C, we had to look on the schedule to see who they are going to vote for next. Because C is not around, they will vote for B. B will have 10 additional votes. The 9 people here, same idea, they won't vote for D anymore. They will still vote for B because they prefer B higher than A. So B will have 9. And in this case, B will have 4. And B will have another 2. As you can see over here, B has a lot more votes than A. B is the winner if I do a runoff between the top 2 candidates. For us to do sequential runoff is a little bit more work. We have to look at the first round. A has 18, B has 12, C has 10, D has 9, and E has 6. Now notice E has the lowest number of votes, so we'll do the vote again with A, B, C, D only. The 18 people still vote for A, 12 people still vote for B, 10 people still vote for C, 9 people still vote for D. You'll notice the only difference here is we had to find out who does the 6 people who originally voted for E, for whom are they going to vote for now? So 4 people here, instead of voting for E, they will vote for B. The 2 people here, they will vote for C. You'll notice A has 18, B has 16, C has 12. D is the lowest number of votes. So D is eliminated. Now we're going to do a vote again with only A, B, and C. A still has 18, B still has 12, C still have 10. The 9 people for D, they will vote for C now. And we still have the 4 people voting for B and the 2 people voting for C. You notice in this case, B is eliminated. B has the lowest number of votes. So in this case, we're going to come down, the voting will come down to A and C. And if we go through the voting again, you'll notice 18 people will vote for A, but no one wants C, right? No one wants A. A is the lowest choice. So you notice 12 people will vote for C, 10 people will vote for C, 9 will vote for C, 4 and 2. And in this case, C is the winner for sequential run. You'll notice in sequential runoff, there's a little bit more steps. As we had to do the voting in multiple rounds. Finally, the fourth method, we have to do the point system. In the point system, we highlight all the instances where the candidate is placed. So for example, if I want to find out how many points does A have, 18 people here will vote for A first. The value of the place for the different position is the following. We always start with 1 for the lowest. So 1, 2, 3, 1, 2, 3, 4, 5. Because we have 5 different choices here, 5 different options here, if it comes in first, that's worth 5 points. So 18 people, they will get 5 points each to A. Now, A is not well liked by the other people. Each of them gets 1 point in that position. Each vote gets a 1 point in the 5th position. So 1 times 12 plus 1 times 10 plus 1 times 9. Okay, it's not very interesting. Plus 1 times 4 plus 1 times 2. And you'll notice in the next page, and you can calculate them and calculate what the total number of points is. This is for A only. What about for B? Well, we have to do the same thing for B. But now B is a little bit different. I have to erase this again. I had to erase this. And I have to locate where B is. B are in different positions now, right? B are in different positions. But I have to find out where B is and in each of the columns. So the 18 people here, they don't like B very much. They're going to give B 1 point. The 12 people, B is their first choice. So 5 times 12. The 10 people over here, they like B second, so 4 times 10. And you get the idea. We just go through each column. We just go through each column and find out and extract the value for points the value of points for each of these columns that our candidate gets. So in this case, that's 4 times 4. And then on the last column, that's 2 times 2. And so we'll do our calculation like this. After you do all the calculations, you'll notice D has the most number of points. It's 191 points. Finally, to do pairwise comparison, it's a lot of work in this case because we have 5 different candidates. Now, if we have 5 different candidates, and I need to find out how many I need to find out how many sort of games are we playing, how many head-to-heads am I comparing. We have A versus B, we have A versus C, A versus D, A versus E. We have quite a lot, B versus C. So remember, we don't have to, order doesn't matter. We're just playing. We're just seeing who comes out on top. So B versus D. It's a bit like the combination that we just did. So it's 5 times 4 divided by 2. So B versus E, and then C versus D. So it's quite a little bit of work. C versus D, C versus E, and then of course D versus. Now in each of them, we have to do a little bit of we have to sort of do A and B voting, and we have to go through the preference table. A gets 18, and B gets like 12 plus 10 plus 9 plus 4 plus 2. We have to do all that, and we can find that B wins, right? B wins, and we can find out with the same thing. C wins, D wins, E wins. Okay, because no one likes A, right? All these people down here, they don't like A. And then we have to compare between B and C to see who wins. Okay, so I had to get another piece of paper on the side, and I had to look at B versus C. And in the first column, the 18 people, they like C more. In the second column, the 12 people, they like B. Third column, 10 people, they like C. And then this column, they like C. This column, they like B. And then this column, they like C. So we had to go through that and find out that C wins. And we had to go through that for all 10 different head-to-head matchups, head-to-head comparisons. Once we do all that, you'll notice E wins more times. E beats everyone. So E is the winner in this case. Now you'll notice we can get different winners with different methods. the 5 methods that we talk about, there's not an absolute fair way to find out which method is the most fair. So whichever method gets you what you want is the best method for you.